All right, so we've got word problems. We're going to use triangles to solve. Imagine that. The thing we've been working on this entire chapter is also in this day. What I want you guys to do now is take some time. It's always important to take time and just read over. This is a 2-sentence word problem. We're going to construct an image based off their description. Just take some time to read. Let's start. We got Jake, and Jake is being taken to prison. So Jake, actually, let's say Jake escapes from prison. That's more exciting. Jake is escaping from prison. I mean, they don't tell us why this dude's heading this direction, so we can make up our own thing. Lily, which way is Jake heading first? 8 miles due north. Okay. So he's heading like that, 8 miles. Okay. Then what happens next, Kinsey?
3 miles.
Okay. So then he hears the dogs barking. They're on his trail. So he heads 3 miles west to try and go through a river, get out of the way a little bit. Well, then, Justin, what does he do then? Okay, so he's like, okay, I think I lost them. I crossed this river, now it's time to head back north to freedom. 7 miles, okay. And then, I don't know what happens. He's about to take a journey here in a second. Jake, what happens, man? Why are you about to head 11 miles due east? I don't know. Let's say he steals a car. And he's about to, that's the only way he can go 11 miles east this quick, I would imagine. He's about to head 11 miles east. So, way over there. Okay. How far is he from the starting point? Now, here's the tricky part. We're asking, how far away is he now from where he began? Let's connect those 2 points. How far away is he now? Because it's direct path. This is what we're trying to find here. Let's call that, what do you guys want to call our variable? Jake, my man. Never again. Let's go with something else. How about D for distance? Yeah, it makes sense. X. You explain to me what X has to do with this. So this is Jake at present. At the present, okay. So guys, how on earth are we going to be able to solve this? We don't really have a shape at all right now. Any ideas?
Pythagorean theorem.
Wow, where did you get that from?
No idea.
Just think we need a triangle to use that. We don't have a triangle yet. Can we drop an altitude though? Or I guess raise up an altitude. Check this out. If I do that right there, I've just created a right triangle. Now we have to be careful because we need to know how far Jake from there to there is. Can we calculate that? From there to there? Absolutely. He went 8 miles north, then 3 miles west. But then how far did he go? Oh, so how long is this piece right here? If you went 8, and then of course the 3 didn't really change anything, and then 7, what's 8 plus 7 going to be, guys? Would that be 15? Yeah. So this piece is 15 miles long. Because he traveled 15 miles north. Now here's where we got to be careful. This is 11 miles from where he turned east to where he stopped. Could we figure out the base of this triangle? What do we need to subtract from that 11 to actually get the triangle? 3, yeah, because we went 3 miles west. Absolutely, so let's take 3 off that. And how long is our actual base of this triangle? 8. Let's go. So now, guys, you've got the height, the base. Like Willie said, we can use the Pythagorean theorem now. A squared plus B squared equals C squared. Or in this case, it would be 15 squared plus 8 squared equals D squared for distance. I'm going to give you guys a second to see if you can solve that for us. Oh, I picked the one person. So let's see. Combine those, you get 289. Oh, I don't know what letter I was going for there. Definitely not X. And guys, don't ever forget, actually try taking the square root of it. It could be a perfect square. Wink, wink. I should go give myself, I don't know what I about did. I winked at the same time, which I think is blinking, but I'm going to have to cut this out from the video. What do we end up getting for our distance? 17 miles, which makes sense. It's our longest side. Yep. So, man, Jake, you put in some work here, man. 17 miles. It's impressive. That is impressive. Now, I'm going to let you guys flex the muscles you just got to flex on day 5. I'm going to give you one quick reminder here. If you want to find an altitude, part 1 over altitude equals altitude over part 2. That's right, we're about to bust out our 2 formulas. If you want to find a leg, depending on the leg, you go with the adjacent part over the leg you're looking for equals the leg you're looking for over the whole hypotenuse. And with that in mind, think back to day 5, what we just did a second ago. I'm going to let you guys see if you can start to piece together and set up number 2. And as you're thinking about that, before you even use these, can we go ahead and use Pythag to find that missing side? Lily, do we have a right triangle here? Yeah, we do. Do we know 2 sides? What's our missing side? C. Yep. We could go ahead and find the hypotenuse. So before you even use these 2 formulas, let's go ahead and find our missing side. So I'm actually going to do this over here. Give myself some room. God. And I think we should get a nice answer when you take the square root of 2,500. I think it's a perfect square. $50 meters. So that's our height. Now I'm going to let you guys see if you can take it from there. This is going to be a little tricky though because we still have to find our pieces. So you may have to use the leg formula, but instead of finding the leg, we'll have to be finding the adjacent parts. May have to go about it that way. You see what I'm saying? You may have to, because we know the legs, fill in using, let's say, leg 1, and use what we know about leg 1 and the hypotenuse to then find the adjacent part, which you may call, we could call that, what would we like to call this? Let's call it Y. And we'll call this piece X, which I guess for me would make 30 leg 1 and 40 leg 2. So this is going to be a little different than what we did before, only because we're not going to be trying to find a leg. We're going to be trying to find the adjacent part. So there's actually not going to be any square rooting here. This is going to be a little bit easier. Check this out, guys. Let's say we're trying to find a Y. That's that is the adjacent part to leg 2. So we would have Y over, what's leg 2's length? 40 equals 40, leg 2, over, what's our hypotenuse? 50. So this is us trying to find part 2 right now. We got to find our parts. That's what's really keeping us from being able to fully solve this problem. So in other words, we're not trying to find a leg, we're trying to find a part adjacent to that leg. And so I think we all could cross multiply and solve this. See if you can do this for both the part 2 and part 1. You end up with 50y equals 1600, and what is that? 30 times 30. Actually, you know what's funny? Do we even need to do this a second time? Once you find out what one piece is, can you do some simple algebra? It's just subtracting to find out what the other piece is? Yeah. I'm about to do all this extra work. You don't need to do that. What did you guys end up getting for y here? 32. So if this piece is 32, you guys can do the math. Figure out what our other piece is. You don't need to do this thing twice. What's that going to mean for part 1? 18. Yeah. And so all that's left to do, guys, we know everything except one thing. We know all the outside stuff. What are we missing now? The altitude. Yeah, we got to figure out what our direct distance is from the parking lot to the beach. We got to find the altitude. I'll call that Z. Yeah, see if you guys, well, you can call it A. I've done X and Y, so Z made sense to me. So we're going to be using our altitude formula, which now that we know the parts is going to make this a lot easier. So your altitude would be part 1, which I called 18, over Z equals Z over 32. And you guys may be pleasantly surprised to see that we end up with a number that can be taken the square root of. We're going to end up with a perfect square. We'll see what you guys end up getting for our altitude. No, try taking the square root of 576. It's actually going to be a nice number. Anybody help her out? What do we end up getting there? 24 meters. Excellent. So I'm going to let you guys answer question A, answer question B, and we will be done for the day. Now that we've got all the information, these 2 questions become a heck of a lot easier. How far is the spot on the beach from the parking lot? And then how far will his place on the beach be from the refreshment stand? Both questions we've technically already answered. So we end up with 24 meters for A, and then Dakota, what'd you get for B? 32. Yep, that was Y. Nice work, guys. Excellent. Don't forget, we got our quiz tonight. It's on Delta Math. It is 6 questions. I'm sorry, 6 questions. So take your time on that. Make sure you knock that out. It's over days 1 through 4. Days 1 through 4. Don't forget about your Delta Math in general. We got Chapter 7 Delta Math that'll be due the day of the test. Some of my people have already got it knocked out. It's very impressive.